Oh, hey guys.
Hello.
Good morning.
Good morning. Let me adjust some order. Hey, actually, you know what? While we're waiting, yeah, I want to try something here. Oh, it's not.
Nice
You
background.
know, but the thing is, it's not animated. Is it spinning? No, it's not spinning. But it's an animated.
No.
Yeah. Okay. So that's what I wanted to try because last quarter, one of the students had a beach background, and the waves were rolling, right, and the palm trees were swaying, and so I asked him, are you actually taking this class from a beach out there? And he said, no, it's actually just a GIF. And so I just picked up an animated GIF off the net, and obviously it's not working. So yeah, so he must have done something else, I guess. So, or maybe there's a different kind of GIF, unless Zoom has an option to have a video background instead of a GIF background. Oh, is it this one? Maybe he was using this one. Yeah, this one.
Oh, this
Yeah,
one
yeah,
looks
yeah.
good.
Oh, I got that. Wow, how did I get that? So this one's a virtual background and it's animated. So yeah,
Is
that's
it part of Zoom?
yeah. It wasn't there last quarter, I don't think, because I asked him, and I'm pretty sure it was different because it was a different picture, but it was just as animated, so it's possible. What does this do? Oh, that is just rotating things. Oh, and it's upside down. It's having a hard time. The machine learning it can identify the face because of the oval, I guess. Yeah. Oh, it's funny. So it's interesting how you can tell a lot of things about how they do this, right? So the recognition and the swapping in and out of the background and everything seems to be built in on top of some pre-processing of the image, which inverts it, right? And that's kind of, I would say, if that was, I don't know if it was done that way, but if it was done that way, then it's bad code factoring, yes? Because if you think about it, then I have to train my machine learning system to recognize 4 different orientations, right? I have to train the system with X amount of data to recognize a face of an upright person. And I have to train it because it's not the same, right? Maybe it's got some, maybe you can build a more sophisticated system that can account for the rotation, but usually it's not the case, right? Usually it can recognize one orientation. So if you expect that you're going to give users the option of looking at the picture in 4 different orientations, then rather than train your machine learning system to have these 4 different orientations, you would basically normalize it first, right? I'm going to present the user so that's why then you can do this rotation 2 times. And then it'll still do the recognition of my body equally well, right? So I can move around. Well, it's doing it now, but upside down, it wasn't doing it before, right? So yeah, look, now it's all gone. Now it's gone because it's not able to do a proper recognition. The system is not trained to do it properly here. But as humans, we know, right? The domain knowledge, that's why I said the power of domain knowledge is that we know as humans that these are the only 4 possible things that we're going to allow the user to experience. So as long as we compensate for exactly those 4 with one simple transformation, right? It's just one transformation. It's just multiply by matrix, right, in constant time. You're done. And after that, I just need 1 machine learning system in the background. I don't need 4. So yeah, those are the kinds of decisions that you will make. And as you can see, this is a decision that you're making about a high-level task, right? About what you're going to do in a machine learning system. But the kind of decision you're making is, if you think about it, you sit down and think about it, the kind of that decision is exactly the same kind of decision that you're making when you're making a choice between should I have a function here, or should I have a function in a different file, or should I have an array or a vector? So all of these are very, very similar kinds of decisions, right? So, and I think that is the danger for beginning programmers, is to identify too strongly with the specific decisions that you're making, right? So, and then they end up remembering millions of rules, right? And they become very, very good at remembering rules and following them, because they know all these little details about all these little things that they need to remember. And so they know, right? So you can say, hey, this is not working, and they could take a look at it and say at this level, yeah, okay, it's not working because the syntax of that thing is wrong, right? So, but that's because they are mapping it to the rule, and they have millions of rules in their head. So how do you get on to be the next level programmer from there, right? Because then you're actually a competent programmer maybe, right? But you're not really a competent computer scientist. So how do you get to be the next level programmer from the place where you have a million rules in your mind, all memorized, right? Because a noob has no rules in their mind, right? A novice, right? A reasonably experienced person, yeah, they have a lot of rules in their mind, but you find that a really, really experienced person, with, a guru, right? They actually don't have any rules in their mind, right? So, well, maybe they have one rule, but it's actually just one rule that they apply to everything, and it works, right? One rule they apply to everything, and it just works. If it doesn't work, then they actually start questioning the rule, right? Why the hell doesn't this rule work? I thought it works everywhere. Why is it not working there? So that is the kind of attitude you have, and you'll find that there is this one rule, right? So as you get more and more expert, you'll be able to abstract away a lot of these data points, right? So because as you start out, you learn lots of data points, right? So I have a point. So as you get further and further away, you can see these points are actually not individual points, but actually on the surface of a sphere, right? So they're all spherically distributed around the center, right? So you can abstract it away and say, well, I don't need all these points. I just need to store the fact that it is a sphere, and it has a center, and it has a radius. Then you have an infinite number of points, right? So yeah, and so on. So and then that way you don't have to remember all these points, right? And in fact, the beauty is that you don't have to. You can even account for points that are not even seen by any other human, because you know that it is just a sphere. It's a sphere described by 4 floating point numbers or something like that, right? And so you don't need to know the individual points. And someone could say, how do you know that this point exists? Nobody has ever seen this point before, right? And you say, yes, it has to exist, because it's, everything else falls into this pattern of a sphere, right? And this has got to exist. So if you think about it, and that is how a lot of scientific progress has been made, right? So lots of people say, this person. They come up with these mystical concepts, right? The mystical concepts saying, "Oh, this is Akashic records," or I don't know, right? So they see these, these things that people like Tesla and all these people, they just see these things, right? They see these things, and somehow it just comes to them in a dream. No, actually, if you think about it, all that's really happened is that we're just being intelligent human beings and just observing lots of things, and not dismissing things that we observe because of stupid reasons, right? Because that's most of the time that's what happens. The reason people don't form good hypotheses, I think, right? Every person has the ability in them, as far as I'm concerned, to form really, really strong, good hypotheses, right? Be very scientific and rational, but most people aren't, right? Most people will just settle for stupid hypotheses, things that they know can't be proven, or even are able to be tested, but they don't want to test it, right? So why is it that people don't do that? And I think that I actually honestly don't know how did we start talking about this yeah, so everybody has it in them, and why don't people I think sometimes why is it that we don't do that? And wow, I had a really good reason. I totally forgot. Okay, well, anyway, what are we supposed to do? What time is it now? 8:12. This is when we're supposed to talk, right? Yes, start class. How many of us are here now? All right, let me see. Let me put back my background, right?
I actually had a question.
Yeah, sure.
I'm not fully understanding structs, and I was hoping we could maybe go over those. Yeah. Okay. Cool.
Yeah. Well, in fact, who was it? Susanna. Susanna was quote unquote. Is Susanna here today? Hang on. Let me see. Look at the participant list. Oh, Susanna got scared off. Okay. All right. Yeah. Okay. So, hey, Susanna's here. Okay. All right. Well, anyway, yeah, I mean, she doesn't have to take the screen, but yeah, someone should take the screen, but with the code that actually, it doesn't matter. It doesn't have to be the code that Susanna worked on, but if you can save about 10 or 15 minutes if we just picked up the code that Susanna wrote. I don't know if she can share it. So you can just pick it up, someone, and replete. pick it up and share it, and then we'll just pick it up from there. So what we can do today is I can show you how now that you have these structs, right? We're going to use structs, Nate. Okay, so now that we have these structs are boxes, right? I think boxes inside of which we put stuff, right? We have a lot of these structs. We can say every time in our system, we're going to give me a new struct, give me a new struct. Okay, you get lots and lots of these structs in memory, but they're not next to each other like a vector, right? So they're all over the place. But however, they have a little hole like beads, right? They're little beads scattered all over, right? So I can show you how you can now link up these beads, right? Today we can do that. So we can take these structs all over the memory, right? And then link them up, right? Link them up like that. And then, so now you have, a linear structure, right? It may be waving around, right? Because as nodes move around in memory, but you still have that structure, right? That threads through each one of your structs. So we can do that. And then also, we're not going to let go of our stack, because I think we'll use a stack as our main character in this drama, right? So what we'll do is, in the process of building this, snaky structure, we will use that to do our stack, which is what we started doing last class, I think, right? Last class, we wanted to build a stack, all right? And the stack was supposed to be made of a bunch of linked pointers. Yeah. All right. So and then these are going to be structs. So it will also answer Nate's question. And structs are just basically classes where everything is public, right? But there is a semantic clue that most or redundant semantic clue that most students, most people usually pass on by using structs, and it's that usually when they say struct, it means that they are using that class as a bag, right? As just a container, instead of saying class public colon, right? So that's the reason.
The one thing in particular that I really didn't understand, so let's say you have some variables inside of a struct, and you initialize them as undefined, but you want to assign certain values to them. I completely blanked on how you should do that.
Oh, okay. All right. Yeah. So we're going to do that a lot today.
Okay,
fact,
cool.
Right. So a lot of that, because our box is basically a struct, right? And then we'll just go around assigning things, and we're going to use that as a container.
Sounds good. Thanks.
All right. So yeah, until someone picks up the screen, so we can continue talking. What is it that we were talking about? Yeah, so making these decisions, and it's all the same, right? So when you're making these trade-offs, so that's right. So when you're that's right. Yeah. Okay. So yeah, there's this, and then right. So when people make these, and they come up with really crazy reasons, right, as to why. That's right. Tesla and all these people, right? They can come up with these ideas, brilliant ideas, all of a sudden, bam, and people say, oh, it's inexplicable, right? So they just tapped into some mysterious field out there. But really, I think, and this is again a hypothesis, right? It's a hypothesis. I think what happens is that they just like, without dismissing facts, right? Because most people are not able to form good hypotheses because they just dismiss facts, right? Dismiss facts as not possible, not tenable, does not agree with my sense of values, right? So dismiss, right? Dismiss. But if you don't dismiss facts and you're a good scientist, right? Good, it doesn't mean what I mean by good scientist is that you have a scientific bent of mind, right? You can be an accomplished scientist, even an ostentatiously rational one, right? Like Richard Dawkins, for example, right? So in fact, even him, I saw in an opera or some, a long time ago, an opera, and he made a very, very completely, utterly unscientific statement right on stage in front of everybody, right? It's a subjective statement, but it maybe made it unjust, but it should not be made unjust in such a way that you attach value to it, right? Because a true scientist never attaches values to facts. They observe facts. So what happens is that when you observe a lot of facts as a true scientist, right? Not as just some random Joe, right? Just random Joes will dismiss a lot of these facts. But as a true scientist, if you observe a lot of facts, then you get to see the sphere, right? Because otherwise, then you can interpolate. Because you get a lot of points. You get a lot of points around the sphere. This is metaphorically speaking. It's not a sphere, right? But you can interpolate. You get a lot of points. You get a lot of data points. And from the lot of data points, you say, well, obviously, there's no way I can remember all these data points. So let me now use something like the minimum description length principle or something like that, right? So a Bayesian model in your mind to make things tractable, possible for you to remember, possible for you to make sense of. You say, I can't possibly remember everything, right? So I'm just going to remember a rule, right? A rule which basically takes up like 5 bytes or 50 bytes of memory. That's all, right? Only 50 bytes in my memory, and with this 50 bytes, I now have the power to know whether any damn point in the surface is possible or not, because I know, right? Is that point on the surface of this hypothetical sphere, right? So and then I think what happens is that these people basically just suddenly abstract out and say, well, no, I see everything, therefore I can just see the overarching rule, right? So I have this rule in my mind, so I don't have to remember these individual points. I can calculate these points anytime I want. And I think that is in many ways a mark of good laziness, right? Good laziness meaning that you accept the fact that as programmers or mathematicians or scientists even, right? So we want to actually be doing as little work as possible, meaning not as little mindless, unenjoyable work as possible, right? So meaning that it doesn't mean that sit around and just keep chilling away, right? It just means that now you have the opportunity to do whatever the hell you want. Right. So it doesn't mean that you have to do something for something, right? So you can basically do whatever the hell you want.
Good morning, Professor Ann.
Hey, sorry, hey, Susanna. Thank you for interrupting.
Yeah. I could take over the screen if you want. It's just I can't talk as much today because someone came.
Yeah, sure.
Yeah.
No worries. Yeah, sure. I'm surprised nobody's volunteered. Is it because I'm just talking? And so I told you I'm going to talk until someone volunteers. Hey, Susanna can't talk, right? She, in fact, she was kind enough to offer, but she said she can't talk. So here is a chance, guys. This is going to be a fantastic experience, right? Because we're all just coding off the bat. We're all coding off the bat, and here you are. If you've never ever coded a linked data structure before, here we are, right? We're just going to do it in the next 20-30 minutes. We're just going to do a linked data structure right here in class. Not you, right? We're going to talk through it, right? And do it, and it's going to be fun. I bet you it's going to be fun, right? It's going to be fun because we'll do some toStrings, we'll print it out and play around, and we'll find a lot of really cool things to do. All right, so go ahead. Someone please pick up the screen. Otherwise, Susanna, that's fine. You should do it. Give them about 5 to 10 seconds more. Otherwise, pick up the screen, and you don't have to talk, right? As it is, I talk quite a lot. So I think that's fine, right? So if anybody else wants to take the screen, this is your great chance. Okay. Yeah, I know that so many people are even missing. Yeah, that's great. Thank you, Michael. And hey, Michael, is this Susanna's code?
Well, yeah, I actually forked it.
Oh, great. Okay, thank you. Great. Thank you, Michael. Yeah, I can see it. Hey, actually, this is a great idea. A great time for me to check this out. Okay. So I went to this one. I got 2 of these, right? So I went to the dollar store and I got a couple of these glasses. So I want to see if it makes it easier for me to read. Wow, it makes it so much easier. So much easier for me to read from here. Okay. Wait, let me try the other one. Wait. Okay. Yeah, okay, this one not so much. Yeah, okay, oh, that's only $1. And I thought it wasn't gonna work. Okay, all right. Well, hopefully it doesn't, spook you guys wearing 2 sets of glasses like this. But that's funny. It's kind of cool. All right. Hey, actually, you know what? If I look at myself, it doesn't look like I'm wearing 2 glasses. Well, maybe if I pin, I can see my full screen. Yeah, okay, well, it looks really weird. Okay, all right, okay, but so you just have to get my video frame out of your gallery, okay? So then you can concentrate on your class. All right, great. Let's go to all right, to main. Let me take a quick look. Class track mode. All right, and you got a private variable top of stack, right? And you got a constructor and a destructor. And you got some methods there.
Yep.
Yeah. Okay. All right. Let's go ahead. What I'd like is let's also have a private toString method because I was thinking about the toString method this morning, and I thought it'll be fun to add a toString method just so we can have a little bit of fun with the stack, right? So you can see the stack and see print out and things like that. So yeah, string, toString, toString, and then that's not going to change the object. So you can say const, and let me say something to Nate. No, just put a semicolon after the const. We'll implement it later, right? So Nate, you see that struct there, struct node. Nate? No, where's Nate? Hey, Nate.
It was Michael who took the screen.
No, but Nate had a question.
Oh.
Nate, you had a question, right? Maybe he's just stepped out. Okay, anyway, hopefully he'll look at the recording. Okay, so that is your structure. And that struct can be outside too, right? It can be anywhere you want. We just chose to place it inside. But the point of a struct is that basically it's just a class. Let's do a really quick change for Nate's benefit when he comes back. And then we can put it back to this, Michael. If you remember how it looks like now, look, this is what we'll come back to. But this Nate is exactly the same as change the word struct into class. Change the word struct into class. And then inside of node, make everything public, right? The very first thing you say is public colon. Yeah, so that is basically what we did. So that is basically our struct. And you see, this is exactly the same, but it's more verbose. And also, class, when I say class, many programmers who read your code will instinctively think, well, there's probably some methods attached to it and there's more advanced stuff. You're right. So struct is very self-explanatory. Hey, hang on. Hey, Peter. Here. Well, he wants an acorn. Oh, you know what? I did that test and I finally find out that he prefers acorns to what was that? Walnuts. So walnuts were his favorite, absolute favorite. And then he started to like acorns. Here. Okay. Yeah, walnuts. So did you see that? So I could give him a walnut, a shelled walnut. So he just has to bite into it, and then I could give him an acorn at the same time, and he'll always go for the acorn. So it's really funny. So I just got a whole bunch of acorns for him. So anyway, it's cheaper too, right? Anyway. What's going on? All right, so you can put it back to struct. Thank you very much, Michael, for doing that. Well, actually, you know what? This is more of a bother to me with these classes. So I'm gonna try and see if I can figure out a better solution. Right? Okay. All right. Actually, this looks clearer. All right. Okay. All right, so struct. Now what we want to do is we have the toString. We'll come back to this toString and implement later on, but we'll implement all the core methods now. So in our constructor, that's the first method starting at line 27. You have to complete it. It says stack double colon. It needs to say stack double colon stack, right? So the name of the method is also missing there, right? So that is a constructor, and that all the constructor does is that here's your stack. And it's empty, right? And we say it's empty because you have to imagine this. And if you really want me to, I can turn the iPad into a whiteboard and basically draw it out. But I don't have to draw it out, I think. If you want me to, let me know, right? And again, don't say in chat, okay? I don't even have the chat window here. You got to speak up. But it's easy to visualize, right? So. Right? So all we're really going to do is our stack is basically a null pointer right now. And then when we push something on the stack, you're going to create a box. You're going to create a box on the heap and then push that on a stack. So we're going to do those push operations and then we'll just visualize them and then act it out with fingers and hands. Okay. And then if necessary, we'll also do it on a piece of paper, whiteboard, right? So let's take a look at the push operation now, right? So let's try and push something on a stack, right? So push, let's implement the push operation. So stack, and then it's going to return a bool, right? So bool, thank you, Michael, right? Push, right? And then push is going to take a string and it's going to push the string on the stack. Here, what we're going to do is, in order to push the string on the stack, this string can't go by itself, right? It needs to go in a box and the box needs to go on a stack, right? So let's first create a box, right? So we're going to say node. So that's our type, right? We just created a data type, and Nate again, right? So node is the name of the data type we created. Just like if it was a class, we would be using class as a data type, right? So struct is also, right? So with node is a data type, like an int or a char, right? So node space, node space, we're creating a node, right? And then star, and then you say node p in lowercase, right? Immediately after the star, no space, node p, node p, right? And then equals, and then you can remove the star, you can remove the space after the star, because usually, right? So all right, new, and then you open a brace, node, new node. That's fine. I think, in fact, you may not even need to have the open close parentheses. You can just say node, right? No, node, and then semicolon should work, right? Just a semicolon should work. I think that should work. Okay. Now that we've got the new node, now we're going to go inside the node. And so here's some syntax, right? So very few times in your life as a C++ programmer, you have to learn new syntax, right? And it's usually confined to the first, 1 year. The first year of being a programmer, you pretty much come up with new syntaxes that is, initially a little mind-boggling, but you get used to it. It's pretty, it's like, articles in English, right? A and so on, right? So here we're going to say a node P, right? So I'll explain it later. So node P, and then we're going to say arrow, right? Arrow. So that is dash. Dash greater than. Hey, Michael, you know these things already. It appears, but do it a little, do it a little slowly, because I don't want the others to feel overwhelmed.
No problem.
Okay. All right, cool. It's a real danger in CS2A, especially towards the end, when lots of students are going fast, and others will basically drop off. The drop-off rate is higher, and it's a pity. Right? Even if they drop off now, they should drop off in a good way. All right. Well, he's back already. I'll give him some walnuts this time. Go ahead, and then what is it? Node P arrow. What are the two parts of node P? String, right? String. What is data? Data, and then assign data to S. Hey, Peter, come here. Oh, he's gone. And then data. Data equals S. And then you also want to say node P arrow next equals arrow next. Is this next? What is it called? What is the next thing called? Next equals a top of stack.
This is really cool, by the way. I didn't know you could do that arrow notation.
In fact, I was going to say that after we do that, let's comment it out and do the same thing without the arrow notation, right? When you say it's exactly the same, but it's not now. Let's finish it off. Undo a couple of times, right? Top of stack, and then we need one more, right? So we have to picture this. What we're doing is that here's our stack. And here is our pointer to the top of the stack, okay? And currently it's pointing to, it's my finger's out of the frame, right? Because I'm not even looking at myself. Okay, is this better? Can you see my finger? Okay, that's my stack, okay? And that's my pointer. It's my pointer, okay? Pointer to the top of the stack, okay? So that's, and basically the stack starts from here and it's linked, okay? It's a box that links to another box, and that's the top. And every time you push something new, what's going to happen is a new box is going to come. It's going to go here, and then that new box is going to say, my next is pointing the current top of the stack, and the current top of the stack is pointing to me. Therefore, if you just jiggle things around, it becomes top of stack points to the new guy, and new guy points to the previously best guy. All right, so can you imagine how that happens? Okay, that's basically what we're doing now. It's a very, very small dance, okay? But when you learn ballet, there's one move that, it looks really, really complex. And then down the line, you're probably doing that move every moment of your dance. You don't even know, right? Because it's become second nature to you. It's like that, right? So just manipulating these pointers and linking things around. Initially, it seems a bit mind-boggling, and also, a little It's scary. It's also scary because you're now stepping into space that is previously, not even, previously, you can't even see, right? You can only operate through logic, right? It's like performing a surgery, right? It's performing a surgery remotely, right? Relying on robots to do the work, or whatever, right? So you're doing this and just looking for feedback, right? So, and here's the thing, right? We're doing things to the stack. We have no idea if it's working or not. Right, so that's the beauty of this whole thing, is that we're doing things to the stack, but we have no idea whether it's working or not. That's why we wrote this two-string method. The two-string method is going to help us to give a, and it's private, right? It's private. Yeah, okay, we'll make it public. Okay, so later, not now, right? We'll make it, so we'll make a public two-string method, which basically just gives us a pictorial representation of the stack at any moment in time, right? And that way we can actually do things to the stack and then do two-string, right? And then see if what we do is actually happening or not, okay? And then it's really cool because exactly the same code will turn into a linked list, right? On Thursday. Oh, by the way, Thursday is our last class, right? Thursday is the last class?
I think so.
Right, next week, the finals. Oh, yeah. Nobody's nominating people for the most helpful member. And that's funny. I've received nominations from other classes, right? But not from 2A. You should feel free to nominate, not just your own classmates, right? Should nominate past students. And by the way, I've also come to the tentative conclusion that from next quarter onwards, participation is going to be such that you can't just do a quest by looking at all the past Reddit posts and saying, I never asked to have to participate on Reddit because I can just go and find a solution on Reddit. So I did struggle, but I never. So if people said that, they're getting 0 for participation, right? So and I think because that's, I think, is how it's turning out to be, because most people are just looking at all the past posts and people have struggled in the past, right? And they are living off the struggles of past people without really appreciating what they went through, right? So it's just looking up the solutions and implementing them, looking up and implementing them, and that really doesn't contribute to a sense of community either, or development as a programmer. So I think from next quarter, I'm going to say that if you basically just pick up a solution by from a past subredditor and implement it as your own, it is fine, but as long as you demonstrate some evidence of having struggled with the problem first, right? Without looking at the subreddit, have you tried to understand what you're trying to do, right? What's going on? You can't say, well, I had these doubts, then I tried and Googled, found this solution on Stack Overflow or subreddit from 2 or 3 quarters ago. That's not an answer, okay? Then, well, they can give you credit, right? You get credit from the questing site or Stack Overflow or Google, right? You can get credit from Foothill. So in order to get credit from Foothill, you have to demonstrate good class citizenship, right? And actually show evidence that you have struggled with these problems that people have been, struggling with for a long time, and say, and then finally say, well, I have been struggling with that, and here's my post. But then these past posts have solved that problem. And this is my understanding how they solve the problem, or say something about it, right? Rather than say, hey, I solved the problem, here are some past posts that'll also help you, right? What good does that do? That really is not participation at all. And so I think that I've got to make that I'm just about to do the syllabus for the spring quarter over the next couple of days. Maybe I'll build that in.
What if we if we're taking from the subreddit, what if we commented on the post that we take it from and explain like where we got stuck and how it helped us?
Yeah, totally, absolutely. I think that is fine. That is fine. I think that what's not coming through is that other than a select few of you guys, especially I think in the higher level classes like 2C, there's only a select few that are showing evidence of struggling, right? And the others are also passing the quests, right? They're passing the quests, well, maybe not so much. And I can see they're struggling, right? I can see they're struggling, and many times they're also struggling the unwise way, right? So again, you'll find this when you use major in machine learning and so on, right? With data, you'll find there's good ways to train a system and there's bad ways to train a system, right? So the bad way to train a system is, well, just throw shit tons of data at it, right? So data, lots and lots of data. Eventually, by the law of averages, the system will figure out, right, what works and what doesn't, right? Most of that, that thing will be, the mean will be identified or something like that, right? So the good way is to apply some domain knowledge, right? So, and say, well, I don't want to overburden the system with lots of irrelevant data, right? So let me weed out all the unnecessary stuff. Yeah, well, now he's back. And basically, yeah, hang on, Peter. Here you go. No, I'm just going to give him a walnut, okay? So here. Here. Okay.
I actually had a question about
Yeah.
about the arrow notation. Why aren't we using like, well, the star that indicates a pointer before each node P arrow?
Right. So let's do it the other way. Yes, thank you,
Okay.
Nate. We'll do it also the way that you just suggested. Yeah.
Okay. Yeah.
Okay. All right. Cool. All right. So let's complete this, and then we want to say top of stack equals node P. Top of stack equals node P, and that basically completes our push operation, right? It's supposed to return bool. What is it supposed to return a bool for? Just make it return a void, right? This is no void, no return, right? Void, yeah, pop should be void, and then also change the, yeah. For now, right? We'll make it a void. All right, so now let's do it, and now let's put the whole thing in comments and do not the whole thing after the declaration, right? All the arrow stuff, right? Yeah, all that. Put that in comments. And let's do it according to the way that Nate suggested, okay? So we say node P, no, star node P. Hey, you're back already. Maybe it's not Peter. There were those, the other guy with the gray tail, I call him Ash, right? He started coming by after Peter, after he saw Peter come by here. Okay, this is the last one, okay? So come back after 12 o'clock, okay? I have a meeting and then I'll go on after that. Okay. Yeah. What was I saying? Yeah. Okay. So we're going to do this according to how Nate, right? So star node P and put the whole thing within parentheses, right? Put the whole thing in. So now that is basically our node object. It's not a pointer to the node. It is actually the node itself. Now that you can do a dot, right? So you can put a dot. You can say, what is it? Dot data equals S. Yeah, and then you can complete the rest too, right? Dot next equals top of stack.
That's really cool.
Yeah, so exactly the same. And but you see how this is more painful to type. I don't know if it's more. For me, it's more painful to type this way, right? Because the thing is basically a shift. So two keys at the same time. Yeah. Anytime you have to have two keys at the same time, it doesn't count as two keys, right? It counts as like 2 to the n keys, right? Because it's 2 at the same time, which is crazy, right? So I think these things can be worked into some kind of a calculus to figure out what notation lends itself to easy typing, right? So I think with arrow, hyphen does not need a shift. Oh, I see. The greater than needs a shift. But because the right shift is very close to the greater than, you can just use 2 fingers and it doesn't mentally register as a shift. Whereas with the other kind of shift, you got to hit the shift and the 8, which is like far away, right? So those kinds of things kind of factor in. But these are things that machine learning can figure out. So if you let machine learning figure out the right syntax based on the keyboard layout and the time people take between 2 taps, all those things, eventually this thing will boil out, right, of the data. If you just don't throw a lot of it. So that is where, a lot of people think, machine learning or AI in general is the art of learning to use these crazy systems and learning how they work, right? So in my experience, and I might be wrong, right? So, but I don't know how it could possibly be different, right? Because, mathematics is the same ever since, right? So what I've found is that that's only half the equation, right? So 50% of the picture in machine learning or AI is to do with understanding the system, and also mastering the API, right? So because just like any API you get out there, like Unreal or Unity, this is hundreds of calls, right? Many different objects you need to know what they look like. All these Lego pieces, right? You need to understand. That'll take a bit of time and getting used to and using them in different contexts, so you actually understand the utility, right? So that'll take a lot of time. So if you pick up a system like Azure or Sage or Amazon or one of these systems, right? So and then you have to stick with it and pick the framework, or decision tree or something like that, or a mix or K-means or DeepNet, right? And you have to understand the parameters and so on, and see that takes a little while, but maybe even that can be made easier by saying, okay, well, I'm not even going to understand things. I just assume that's a deep neural net, right? So a neural net, so the probabilities inside, the distributions inside will somehow take care of the model, right? In some n-dimensional space, which I don't know. And I don't care to know as long as the model performs as per my expectations, right? So I'm just going to train it, just like, a squirrel, right? You train it to perform a particular task. You don't know if the squirrel basically thinks of you as a kind human being, or it basically thinks of you as a tree, right? Every time that you go to a tree and basically bonk your head on the trunk, sometimes a loose fruit may fall, right? And it may take the fruit away. So you don't know, right? So the best hypothesis you can make at that point is, well, maybe the squirrel actually thinks that I am a human because I can project a little bit of me thinking like a human, right? Thinking like a human, I can take me and project that into the squirrel. And for all I know, the squirrel could be an automaton, right? Maybe a robot that, some kid next door is driving, right? So it may not be thinking, right? But it helps me to think that, there's a little bit of me in that squirrel. And that's how I can actually make sense of the squirrel's actions, right? So likewise, with the deep neural net, what we say is that, we don't know. We don't know how these probabilities embody the desired behavior, but they do. Right, but they do, and so we, but we find it harder to anthropomorphize with these things. But if there are a sufficient number of behaviors that we train the system to do that are very human-like, like take a robot, right? Just take a robot and with a chip built in, and eventually it starts training, like right, and it becomes more and more human. Then we find it easier, right? It's equally easy, right? There's no less reason for us to imbue the robot with a human-like soul than it is to imbue some data bank in the heart of Alaska, right? So deep within the earth, right? So Antarctica, right? So they're pretty much the same, but it's harder for us to think that that's a human, but it's not as much hard to think that a robot that looks like a human, with flesh-like thing and everything, right? So it's harder. So we can it's easier for us. So ultimately it's all back to us, right? So it's easier for us to project our own selves, right? Ultimately, even if I look at another human being, how can I tell that they're thinking and acting and feeling things like me? No, I can't. The only thing I can tell is that that person, if I were in those shoes, if I were in the same shoes as that person, that's how I'd behave, right? So I would basically say, that's what that person is probably feeling now. That person is feeling indignation, anger, hurt, all those things, because if I were in those shoes, instead of that person, and I experienced what I think they did, right? Because you have no idea what they really experienced, right? So if I experience which I think they did in their shoes, this is what they would be feeling. And therefore, I just come to the conclusion, but this is what that other person is thinking, right? So ultimately, at the end of the day, if I sit down and think about it, I have no evidence, right? As a scientist, I have no evidence that this other person actually thinks what I thought they did. The only evidence I have is that, I know what I would have thought if I had been in that situation with the data that I process, with the kind of ways in which I process data, and only seen the stuff that I have, right? Without having, not all these crazy things, right? So and humans, we make this assumption all the time. And so with AI systems, I think what we do with deep nets is, we just train the system sufficiently to imagine, to believe that in most of the cases it's producing desired output. So that's only part of the, I think that's part of the equation. But I think, in fact, if I'm not mistaken, it's even more than that, right? That's probably only 25%, right? 25% or less of your entire ingenuity that you bring to bear as a machine learning or AI researcher or a scientist or an engineer or a product designer, right? The ingenuity, I think it would be fair to say, right? And correct me later on, that less than 25% of the expertise you bring to bear on a machine learning problem is to do with understanding the system or even understanding the logic and everything behind it, right? So it's, even then, it's important, but it's only 25%. It's 75% of the ingenuity that I have found, right? Between two people who may know exactly the same thing, right? So they have exactly the same thing about the model and everything. But I found that the better engineer is a person who can identify the right data to train the system. This is exactly, they're both training on the same system, right? And they're also both, it is this person who brings, that's ultimately what everybody pays for, right? Everybody pays for just domain knowledge, right? Because the systems, the way things are done out there is being commoditized, right? Everybody just thinks the best possible with the best of the industry out there is out there. It's going to be in Vegas and CES and all these places. Everybody's going to adopt it within a matter of 10 years. Everybody will have it, right? So what is it that people bring to bear that is of lasting and real value? It's really the ingenuity, right? So that keeps, and I think that the power of domain, right? The power of domain knowledge is what people always pay for, because that's where you bring something into the mix of things that other people have not seen. Because other people, everybody else has seen all the latest machine learning literature out there. It's published, right? It's out there. I just have to go a quick Google out there, right? Go to the library, I find all the literature. It's out there, right? So it's all fair game, right? So if you really want to create something absolutely fantastic that other people have not been able to, then you actually been able to spot something in the domain that you're interested in, right? That other people cannot, because they're just looking at the overall strengths, right? So that's why great, I think, right? Great progress and great achievements have been made by people that just focus on a domain, right? Because if you focus everywhere, you may be really, really bright. When you focus everywhere, chances of finding domain-specific knowledge to your advantage is very slim, right? Whereas you bring your entire expertise to bear on something that you're interested in, right? But it's only a small amount, right? So but then you have more and more knowledge of the domain. When you have more and more knowledge of the domain, then you can say, well, I can take these standard algorithms out there, right? The best that people have been able to use these algorithms out there is this much, right? But with my domain knowledge, I can take the standard algorithms that people are basically struggling with, I can bring them in there, and with my domain knowledge, they basically turn into, Miracle Grow, right? So that is what people will always continue to find a value. And again, with with AI and with development, maybe even that will be automated at some point, right? When maybe the AI system can basically, when given lakes and lakes of data, right, and it can basically just sift through it really quickly, right, and say this is basically what is going to be useful to you, right? Not me, right? Because I'm the genie of the little lamp, right? I don't know how to deal with all the cleverness, but at least I know what is clever and what is not. So that's the first level, right? So one of my friends in Seattle has actually started a company that's doing something very similar with the finance data, right? Because this is amounts of finance data, right? Because if you're interested in only some very specific things, you want all the state-of-the-art knowledge, but you don't want but you want to go one step beyond the state of the knowledge, and you can only do that by leveraging domain data that only you have access to, right? All these other people on Wall Street and Merrill Lynch, they don't have access to it, right? Because if they had access to it, they're brilliant minds. They can figure it out, right? You can't, that I think that is the greatest shortcoming that many people have, is that, I'm the only brilliant mind, everybody else is not a brilliant mind, right? So then they try lots and lots of ideas and they don't work. That's because other people are also brilliant, right? They're also coming up with the same ideas. That's because the playing field is actually pretty level. You may see these little bumps. It's actually pretty level because all the best of the knowledge out there is out there. It's out there. It's freely accessible. It's out there. You can go on Google and find out, right? So so what makes one person really, really successful and not another is because that person has managed to was able to find through luck or through determination not by sticking hard and fast to one particular thing. Determination just to not be distracted by all these other things, right? All these other things. I want to be determined not to look at this stupid Netflix film, right? So even though it's so tempting, so I want to, because this is something I want to, this is more interesting. This is determination. They manage to get so well trained in a particular field that they're able to identify domain specific items that are of value, like a miner that has identified a gold mine or something like that. They've identified something in the domain that other people cannot. Even though they're brilliant, they don't have the advantage that this person is actually in that home at that point in time. They're in there and they're looking at that data. So that way you can be sure that no matter whoever is out there, Merrill Lynch, and they're pouring tons and tons of money in this department, they can come up with an order of magnitude improvement in the algorithm simply because they just don't have the data that you have, right? It's very, very specific. And that is how you can make these really, really strong marks in specific areas. And I think many people are just going for the diffuse thing, right? Saying they're just going to be a master of everything. And it's really hard. So if you focus on the domain, And so I think that's where the, it's also with machine learning is identifying what data. And so 75% of the work in machine learning, any kind of training of a statistical system is really in identifying the exact data, right? Is in identifying the exact data to train a machine learning system. Yeah, and to that extent, what happens is that you will eventually end up writing a lot of filters, data massaging systems, and many times you see the data that goes into the pipeline will be very, very different from the data that comes out, right? So maybe you send in a string of Wikipedia pages, and out the other end you basically get a string of real numbers, right? This is floating point numbers. Who knows, right? Some normalized frequencies of various words. So the process of changing one kind of data into another, and in the process, getting rid of a lot of this data, getting rid of a lot of the useless stuff, which eventually is just going to confuse, right? This is the machine learning system. You get given a brand new pristine machine learning system, you treat it like a little baby, right? Who knows absolutely nothing. So you feed it a lot of trash. Unless the baby is really, really brilliant or has an infinite amount of time, it's going to learn on all the local minima. It's going to make a mess of its life, right? So you want to, at least during the formative time when it's learning, you want to curate the data a little bit and say, only send the sensible stuff, right? So, and that is really where the genius of the data engineer comes in, right? Lots of people think that, I'm going to study data engineering. I want to study data science because I want to learn these complex models. That's only 25% of the picture. I can tell you, right? Terabytes and terabytes of data, lakes and lakes of data. The real genius is in basically sitting down calmly and thinking about what is it that makes it different, right? What is it that makes it different in this domain than from other domains? Therefore, let me just write a very clever set of C++ programs or Python scripts, whatever it takes, right? It'll all come down to these programs that you'll write, right? These will be the pearls that you create, right? So these programs, I'll write a program that will basically take these mountains and mountains of data and filter out, right? And filter out everything that is not contributing to this very specific domain-specific knowledge that I found. So, and then that's where all of this will come to be useful. Hey, that's all. Okay, that's all. I told you to come back after the class. No, that's all. Okay. All right. Yeah. So let's we can do the structure later. What time is it? Gee, I spent a lot of time. Oh, we got a lot of time. All right, cool. Great, 8:50. Top stack. Yeah. All right. So Nate, are you good? So is that? Oh no, we missed out one more. No, that's it. So that is our push operation. Can everybody visualize what's and put a comment above the 3 lines saying exactly same way of doing the exactly something like that, right? Yeah, exactly the same thing in a different way. Yeah. Thanks. So that it's recorded and people refer to it and they'll know. All right, let's do the pop. Right. So in a pop, all we're going to do is we'll just look at the top of the stack. At the top of the stack is a null pointer. You're going to say false. I can't pop anything. Yeah. And it's No, pop doesn't take a parameter, right? Pop just pops whatever is on top of the stack, it pops. Or did it take the parameter in the string in the signature?
Yeah.
Oh, yeah. Get rid of the parameter. Pop doesn't take a parameter.
Should we make it void as well, or do you
No,
want to
I think the parameter list. No. Pop should return a bool saying whether it's successful or not, but it doesn't take a parameter. It just says, I'll pop, right? So get rid of the string s within quotes, within parentheses. Yeah. Just get rid of that. That's all. Right, and then in the body of the pop method, you can basically say if top of stack equals null, if top of stack equals null pointer. Oh, I'm sorry. I wasn't even looking. I'm really sorry, Michael. I was looking at Peter. All right. So return false. If because if the top of the stack is a null pointer, you just return false, right? You can't pop anything. Yeah. Right. Yes or no?
Yep.
Okay, all right. If it's not the null pointer, here's where we're going to do some clever things. Okay, if it's not the null pointer, this is can you see my finger? Okay, so this is my stack. Okay, this is my top of stack. My top of stack is here. Okay, and this is the item. This is the first item, right? It's pointing to the first item, and it's not null, which means it's pointing to a real node. And this node we want to pop. We want to say, right? We want to take that away and get the next one and put it in there. So how do we do that? All we're going to do is take this top of stack pointer. It's pointing to this guy. So instead of pointing to this guy, we're going to take this pointer and say point, and skip over that guy and point here instead. Okay. So we're going to say, don't point to the top of stack, but point to the next of the top of stack. So the top of stack has the next, that's this guy. Okay. So point to that guy. Now, what about this guy? Right, this guy just got unlinked from, this is a bead that got unlinked from, it got out of basically the thread, right? So the magicians do these threads, they pull it through the bead. Okay, the bead is still there, and the thread went right through, right? So you got this, thread that was going through this bead to the next bead, but we just did this trick and we took the thread through the bead. Okay, so that bead got disconnected from the necklace. Okay, so that thread goes directly to the second bead. Now, so far, is that mental picture clear with everybody? Right? I want to, say yes or no, because then, Mike can basically just code that up. Yes or no?
Yeah.
Makes sense.
Yeah. Okay. All right. So, Michael, yeah. So go ahead. Right. So if now top of stack is not empty, right? So we know for sure, because that's why you have to make that check, right? If it's null and then you try and reference something inside of the null, then your program will crash, right? So we check that it's null, it's not null, so we return false. Now we know it's there. So now we say, yeah, node star p, temp, yeah, well, that's fine, temp equals, yeah, top of stack, no, node star temp equals just top of stack, right? Top of stack, because that is the guy the top of stack is the guy who's going to be unlinked, yes? Top of stack is the first node. That's the guy that's the bead that's going to get out of the necklace, and this guy is going to be tossed away. Yes or no?
Yeah.
Yeah.
Yeah. Okay. So just hold on to top of stack. Now you say your top of stack was not what you thought was top of stack, but is actually the next of the top of stack. Top of stack equals top of stack arrow next. Okay, so this is like the craziest line that you have ever typed so far, right? I don't know if you agree with me or not. Okay, but look at that line, and it takes a little while to understand that, right? Your top of stack is not the top of stack anymore, but it is really the next guy. The guy the top of stack points to, that's my top of stack, not the top of stack. So can you understand that? Is that okay? Can we move on?
Yeah.
Okay, now we managed to unlink the bead, but that was actually memory that was allocated on the heap. We asked the operating system every time we push something on the heap, go back to our push, right? So we said new. Oh, we didn't say new. Oh yeah, we did say. So we said new node, right? So we asked the operating system, give me a new box out there in memory. So it gave us a box by allocating that many bytes in memory, right? So it gave that box, and then we unlinked the box. We have to give that box back to the operating system. Otherwise, it's just free memory, right? It's just a free floating memory. And it's called a memory leak, right? When you have memory leaks in your programs will start getting bigger and bigger and bigger and fatter, right? As we get older and older, like get more and more stuff that we don't want, we hold on to, it gets fatter and fatter, right? So what we do here is, we've unlinked it. Now we need to free it. Okay. So you've served your, that node, you've served your purpose. I don't need you anymore. I'll give you back to the operating system. So someone else who needs memory can make use of you, right? So you say delete top of stack. Okay. No, not delete temp, right? Okay. All right. Now you can return true. All right, so that is basically your pop method. Now, does everybody understand what happened in the push and the pop? Now, that's very important. It doesn't matter if you guys need 20 or 30 minutes to experiment with these things, right? Or 15 minutes of your own time, right? 15 minutes of your own time, I'm happy to step away, like as usual, right? So I can just leave you to this code, right? Unless you want me to walk you through more things in TwoString, I can do the TwoString, right? Let's do the TwoString and then I can take off. Is that okay? So I'll do the TwoString.
Sounds good to me.
Yeah, all right. I'll do the TwoString with you. And then I'll take off for about 15 or 20 minutes. I'll just hang around here, right? I'll hang around here, and then
I think you should actually create another pop method where you can get what's on the top as well.
Yes, thank you, Chad. Thank you, Chad, for
because I remember when I learned stack, I think of pop as like grabbing something from the top
Absolutely, yes. Thank you, Chad.
rather than just destroying it.
Yeah.
I mean, it's fine to destroy it afterwards, you know, but
No,
I think the sense
that's fine. We actually did have a chat about this. I think either in Reddit or previously. Great. I'm just thinking of top. What would top do when the stack is empty, right? So we need a string sentinel. So I think the usual way to handle a top on an empty stack is by throwing an exception, but we haven't even covered exceptions so far. So how do we do top if the stack is empty? Yeah, I'm not the only one who's thinking here, okay?
we return a string sentinel.
Yeah, so what would be a good sentinel for a string? I don't know. Because an empty string also could be a valid string, right? I may want to push an empty string on a stack.
Or we can just throw an exception.
No, I think what we should do is basically take top, make top return two values. To make a top return, here's what we'll do, right? Make a top take a parameter by reference, right? Make a top take a parameter by reference, bool, ampersand, bool, ampersand, success. Okay, so in our top, if the top was not empty, if the top was empty, if the stack was empty, if the top was null, then we'd basically return false immediately. So let's do that, and then I think it'll make sense. All right, so let's implement top. Let's implement top. Like we keep.
I don't think we're supposed to return something. We're supposed to just return empty string and set success to false because we're passing.
Hang on. Right. So yeah, let's go ahead, implement it. Implement it. Is everybody following along with what Michael is doing?
Yeah.
Not
Yes.
you, Chad.
Oh yeah, I was actually trying to stay quiet this whole class.
Yeah, absolutely. Yeah, thank you for that. I know. Thank you. All right. Hey, other guys. Yeah, Nate, Susanna, Peter. No, nobody else basically is chiming in. Is this like fast or slow or
This is good.
Come on, tell me. Is
Yeah,
it
I was gonna,
I'll-
I don't have any
following.
comment because it's sort of just, I'm following along, yeah.
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 I was just following along and I can't
is
talk
it,
as much
what
today.
do we need to go slower?
I think this is a good pace.
All right, here's what we'll do. Right after the two-string method, I'm going to give you like a half
Yeah.
hour or something, right? So you guys can play around, ask each other questions, and maybe Michael or Nate or anyone who understands can explain to anyone who doesn't understand. How about that, right? And if nobody understands, you just call out to me. I'll come and explain. Yeah.
Okay.
Sounds good.
You can basically play around with this code, right? So you don't have to understand everything, but hopefully try your best to understand as much as possible. Hey, top, right? Top. So here you say if top of stack equals null, if top of stack equals null, equals null pointer, and then within braces you say success equals false. Success equals false. Return. Just return empty string. It doesn't matter what you return really. Right? We can't return nothing, right? You got to return an empty string. You got to return an empty string. Yeah.
You could also return the string stack as empty as a debug message, right?
Why? Now we know with the Sentinel, which is a 1 bit, we know it.
Oh, never mind.
Yeah, this is easier, isn't it?
I was just talking about if you want to make it user friendly.
Right. Yeah. I don't know. There's many ways. This is easy for me. I don't know. You can obviously do it in other ways too, right?
Yeah.
So if top of stack is not equal to null pointer, then we want to return contents of. Yeah. So now you say return. You say success equals true. Success equals true first. Success equals true. And then you say return top of stack arrow data. Is it data? Or is string, or I think it's data. Top of stack arrow, data. String, yeah, data. All right, so basically that is going to do it. So Chad, or do you see that now? Do you see how this works? I think.
Yeah.
Yeah, it's you can rejigger this however you want, right? So using other ways of. You can say you returns the Boolean value, but the string parameter is passed the reference. That's also possible. Yeah. So you can say, you just return false. So that's the other way you can do it, right? Then let's do it the other way, right? So you can say bool stack top and then take the string as your, if you want, right? No, let's not do it now. You can do it the other way afterwards, right? In your own time, you can do it the other way, right? So you can say it returns the Boolean, but the string parameter, the top value is filled in by reference, right? So you pass a string by reference, right? And then then if it succeeds, it returns true, which means the string value that got filled in was correct. If it failed, it returns false, which means that, you know, that doesn't have anything in it. It's just junk value, whatever you passed in, right? So that might actually be a better way to do it, right? That's a better way, because then you can use top in your Boolean conditionals. You can say if top, right? If top, you can do that. You can do that now, right? Because it's going to return a string. So those are things you can play with. Okay, let's do a toString operation right now. Let's do a string, toString. And then after that, I think I'll give it to you guys, right? What time is it now? Yeah, I think you got time, right? You got time. I don't have to come back until the end of class, right? Last 5 minutes even, you can yank me in when you guys are ready to go. Or even before, anytime, you know, I'll just be here. Okay, so all right, so string to string. Yeah, let's implement that. Let's implement that. That's yeah, implement that and start the implementation. Further down, you say, and we'll also make that public, right? Not, we won't keep that private. We'll just make that public. You can do that anytime later. Yeah. Thanks. Yeah, so this is basically going to create a string with all of the stack contents in it and return it. So what we'll do is, I'm trying to see, right? So here's how we'll print the stack, return the string of the stack, is that it will start with an element within curly braces, you know, within quotes. Within, it's a string, right? It's a string start. So yeah, string within quotes, and then arrow to the next string within quotes, arrow, next string within quotes, and so on and so on and so on, until the very last item, when it's a null pointer, it says null, and that's the end. Okay, so this is what it should look like. So let's say what is it? O string stream. Yeah. O string stream SS, right? And then you may need to include string S stream or something at the top. Hash include S. Oh, there's no hash includes here. Yeah. All right. So now we can just do a really quick. I think we can do it in a. We can do it with a for loop or a while loop or anything. Let's do it in a for loop. Okay. So let's say on the next line, say for node star p equals top of stack. This is, you know, standard idiom. That's why I'm just calling it out from memory, is that this is a standard idiom you use like millions of times in your code. Right? P equals top stack. P is not equal to null. P is not equal to null. Null pointer. Yeah. And then P equals P arrow next. All right. So this is a really, really cool syntax, isn't it? Right. So this is a loop, and it's a standard construct for processing linked data structures, right? So you start with a node, and you process the node, and then you reset the node to the next of the same node, right? So, and then it zips through and you process the node, right? And here, all you want to do is print the contents of P, and then print the arrow sign after that. So print P, print P, what is it? SS, yeah, SS, and then let's say you want to print the double quote within single quotes, right? So you want to print the double quote within single quotes. Yeah, okay. So it's going to print a double quote, and then it's going to print P arrow data, right? And then it's going to print another double quote, right? And then it's going to print. You want to left shift the dash arrow or something like that. Within quotes. You want to print within double quotes. The string a dash, and then it's the same as the the arrow dereference thing. Yeah. Arrow. And then after the for loop is done, In fact, you don't even need the braces for the for loop because it's just one line, right? So you can, it's just the for loop. It's a really tight for loop of just that, right? And then after the for loop is done, you just want to print null pointer, right? On the next line, you say SS, and then say null pointer, and then null pointer, NULL. Just say NULL uppercase or no, whatever you want, right? Null pointer. Whatever you want, right? So you can say that's, or you can say end of list or end of stack or bottom of stack. You can say bot, right? You can say bottom of stack. Yeah, okay. All right, and then what I do is I don't print the new line there. In my two-string methods, I don't print the new line. And again, it's the argument for that I have is exactly the same argument that the people in AT&T Bell Labs had a long time ago when they wrote the echo program, right? When you say echo XYZ, should it print XYZ and then a new line after that or no new line? I think eventually people said there's a lot more sense in printing it without the new line, because if you want the new line, you can always add it, right? If you don't want a new line and the new line is already there, it's harder to get rid of it, right? It's like my mother-in-law used to say, right? In my previous life, my mother-in-law used to say, I was notorious for over salting all my food, right? Every time I made dishes, I would always add extra salt in it. It's actually a very interesting story, right? So, and when I had people over at my home, and people would always ask, which one of these dishes did you make, right? And then I'd say, I made that. And then people would be really, really careful not to try that, right? So they'll try everything else except that the one I made, because, Bayesian inference-wise, right? So everybody had a Bayesian model in which I always had more salt than needed, right? So I had more salt, and it was, I know, it wasn't good. But the one person who was always kind, even though she knew that I oversalted my food and it wasn't really tasty most of the time, she was always kind to try it every single time and give me constructive, in a nice way, was my mother-in-law, and she used to try that. And one time it was really salty and I was about to throw it out, and she actually said, I think, don't throw it out today, throw it out tomorrow. And then the next day I tried it, it wasn't as salty. And apparently maybe it's because the salt on the surface had sunk into the potatoes, or so there were more inside of the places where the tongue does not make contact, right? So this is insightful advice that you hear. Oh yeah, total salt consumption remains the same, but at least it doesn't taste so salty. Anyway, what was I going with that? So it is like salt in many ways at bottom of stack. I don't know where I was going with that. Yeah, adding the new line, right? So yeah, she used to say that, don't add salt in your dish. It's always easy to add more salt, right? But if you oversalt the dish, then you can't remove it as easily, right? So it's harder to get rid of the salt. Then it's just like that. It's always easy to add stuff to stuff that you're sending to a stream. It's always easy to add it, but it's harder to get it out of the stream too, right? There's also a negative way of looking at this whole thing that I heard from a wannabe entrepreneur a long time ago, who was struggling with the idea of whether to award pay raises to his employees when the company actually had a lot of money. They had a lot of money and they could afford to give the money out to the employees. And I said it makes total sense to share that profit with the employees. And they said, and again, this is all part of marketing calculus, I think, that they learn, and actually works out better apparently. I don't know for them. I don't know, right? Does not work out best in the most humanitarian sense of the way, but apparently it works out best for the bean counters. Is that when you have employees and they're already reasonably happy, don't give them more than they need, because when you give them more than they need, it becomes like oxygen, right? It becomes like oxygen and it's just free and they don't even see it, right? It's just out there. Then when you say, well, during a tough time in the company, when you need to take pay down, right? Then you say, you know what, 2 years ago, we gave you a raise because the company was doing really well. Now the company is really doing badly and we need the money. So can you take a pay cut? And everybody will be really, really hard, disgruntled and unhappy because they don't see the money coming in, but they see the money going out, right? And so that's their reason, right? It's not a bad reason. right? But again, it's a negative way of portraying the same thing, right? Adding the salt is easy, but taking the salt out is hard. And that person was telling me the same story from a financial mindset, saying that as a good financial manager, not as a good humanitarian manager, right? As a good financial manager, you should not over reward your employees, right? Because if you over reward your employees, then you're actually doing them a disfavor, right? Because you give them a lot of invisible stuff that is just going to make it unhappy, cause them a grief later on in life, because it's invisible. It doesn't impact their life anyway. But if you take it away later on, or they're going to lose it anyway, right? Because it was invisible, they're going to lose it anyway. But when it's gone, they'll notice it, right? When it's gone, they'll notice it, and there's unhappiness, right? So you're giving them nothing, but you're giving them future unhappiness. That's really what they're reasoning is, and I can't argue with that, really, right? So, but the point is, many managers who are not humanitarian will take that to an extreme and not even take the employees into consideration and say, I'm not going to give you more than what you need, but I'm not even going to give you what you need, right? So in other words, they have employees working for their bread and butter, right? And that really is also not the best way to get the best out of anyone you want to be working with you. Anyway, all right, bottom of stack, that's it. And now you can return ss.str, right? So that is your, let's go to main and experiment, do a really quick experiment. Is that it? Oh, destructor, let's do the destructor, right? You want to do the destructor? You guys want to do the destructor yourself? Yeah, you can do it iteratively, right? Do it iteratively. Do you guys want to do the destructor yourself? Or do you want me to walk through it?
I'm good with
Actually, I
either.
would probably prefer.
We could walk through it.
Walkthrough sounds better.
No, wait. But yeah, sure. Happy to walk through it, but Michael said he can do it, right? Michael, you can do it, right?
Well, I'd rather you do it.
Yeah, but someone said who can. They want to do the destructor. Nobody wants to do the destructor.
I'm good either way.
Okay, yeah, do it. So I'll stick around then. I'll stick around until the destructor is done. You do it. I'll stick around, and then I can take off after the destructor is done, and then we do a little experiment in main. Yeah, go ahead. So you can talk Michael through the destructor. And you can also ask me. You can ask me by saying, hey, chime in, or I can chime in, right? I can chime in anyway if you want. So you can go ahead. Or if you want me to just talk him through it, this is 2 lines. This is 2 lines.
I'm guessing you're just going to use pop to do it.
You can do that too.
Do like a,
also, yeah. Wow, that is totally cool. Who said that?
Me, Michael.
Right. Yeah, Michael, that is absolutely nice. However, don't do it that way, right? So what Michael is doing, saying is that in the destructor, he just keeps on doing pop until the stack is empty. Until the stack is empty. Yes or no, Michael?
Yeah.
Right. So that's what he's saying.
Yeah.
Does everybody understand that that is good enough to clear the stack and release all the memory? Because you don't want to be deleting the stack and leaving boxes of memory out there that were allocated to you. Yes?
Correct.
Yeah.
Right. So what Michael suggested works. It works. Yes or no?
Yes.
Okay.
Works,
all right.
yeah.
Good. All right. So that's great. So that's fantastic. That is a solution. Although my personal preference, you're right, this is my personal preference, is that every time you have a class, you, in your mind, right, and I'm pretty sure you will too at the end, right? You have 2 families of functions, right? 2 families of methods. One set of methods work with the guts of the class, and you call them the core methods, right? The core methods, right? These core methods, like the heart of the system, right? The other, not so much, but they still work with the system, but slightly. So you have the inner circle and the outer circle. Eventually, you'll come up with every class, every sophisticated class, starting from stack, right? These core methods, and there's not so core methods. Now, push, pop, tag, destructor, constructor, they're all core methods. They're all really part of it. So in my experience, I've found that when I identify a bunch of core methods, I try to implement the core methods with absolutely no dependencies, right? Or as minimal dependencies as possible, even amongst each other. Meaning that if a core method is wrong, it does not affect anything else around it. Yes?
Yeah.
Right? Because the core method, so many things depend on the core method. If one thing is wrong, you want to make sure that the damage is self-contained, right? So there, so I try and make sure that all my core methods, even though they can invoke each other, especially constructors, right? Constructors are notorious because in constructors, it's even worse. You can't even signal back unless you throw an exception. And an exception, if you don't catch it, will percolate downstairs and downstream and kill everything. Nasty stuff, right? So constructors are notorious. So all of these, you try and keep it as ideally, right? All these core methods should not be more than 5 lines of code, right? All your core methods should be really, really tight. And by just looking at it like that on your phone, right? You should know what they do, right? So if they're like that, you're really good, right? I mean, good meaning you're set up for a peace. You're set up for a lot of peace, right? Because I can tell you right now that the people that have the worst possible time debugging their code later on are the ones who have bugs in their core methods, right? If you have bugs in the superficial methods, you can find them, right? Fix. If you have bugs in the core methods, you're screwed. Right? It's like a virus invading your DNA, right? You're basically fucked at that point. So that's why in my core methods, like destructor, I basically try and say only primitives, right? So here I would do it using a for loop. Yeah, while top of pointer, while whatever, while. So you can just say free. Oh yeah, yes. Thank you. Thanks. Yeah, that's it. Yeah, I think. Can we do it? Yeah, I think that's probably as fast as you can get it, right? I mean, you can do it in a for loop too, but it's exactly the same. That's good. I think that should do it. Yes. Yes or no? Right.
Yes.
Now we can go to main. We can go to main, create a stack, push a few things on it, then print a stack. Right. So go to your main, create a stack, go to your main, include your stack.h.
You're in read-only editor. I don't know why.
Oh yeah. Why is that?
Not too sure, actually. Okay.
Oh, the whole thing became read-only, or only stack or main.
The only main. Yeah.
Yeah, I just create a brand new main. Yeah. Hey, what happened to your stack.h?
It's still there.
Still
Okay,
there.
but you're not showing. Oh, I see. Is everybody following along? Right?
I'm watching you.
Yeah.
Oh, I'm just following.
Me, it's
Yeah, create a stack. No, we just say stack, my stack, space my stack. Right? And then that's it, semicolon, right? And then right now, right off the bat, you can do an cout my stack.toString. Yeah, endl. Now you can put the endl there, right? Because now imagine if you didn't want the new line and that had new line, it'd be harder, right? Now before your my stack, also annotated saying original or new stack, or saying cout. No, right there after the cout, when you have the left shift, right before my stack.toString, you say you say original stack or new stack /n. Okay, all right. So now if you run it, you should actually see the new stack with empty. Why is it using namespace? Why is it underlined? What's going on? Cout double less than new stack is underlined.
The strings. Yeah, the strings. I think we need to qualify them with the STD namespace.
Oh yes, thanks. Oh, in stack.h, not in main.
Yeah.
Oh, you got two more on top of that. Top and toString, yeah.
You could also just do using namespace std on the header.
No. That's what. So the reason why Michael is not doing that, I think, relates to something that we went over a few lectures ago. We try not to include using namespace in header files, just the same reason as adding a new line, right? Because if you have a namespace, using namespace in your header file, other people who include your header file can't unuse it.
Got it.
Yeah, but otherwise, then you can just include your header file and use namespace. Yeah, so did you run it? Oh, it isn't running? It's empty. Oh, you don't have is empty?
Oh, I think, no, I think the is empty, actually. Bool stack is empty.
Oh, const, you're missing the const.
Oh.
Oh, you forgot semicolon after the end of the class.
So it's struct.
No, I mean after struct it says.
Okay.
There you go. New stack, bottom of stack. Do you see that? Now you can also push a couple of values, pop up a couple of values, and print the stack after pushing and popping. You know, those are experiments you guys can do on your own, right? Push, pop, and try and pop from an empty stack and see what the value is. And it's not crashing your program. All of those things, right? So you can try and do all these funky things with the stack. Yeah, you can copy and paste the cout right there. How about that? Really cool, huh? Now, when you pop, you only get world. You won't get hello, right? So when you pop, you get a. When you do a top of stack is hello, right? Not world. If you pop, you don't get anything, right? So hello is lost. Yeah. No, I think it was. No, that's not what how we did it. Did we do it that way?
I don't remember.
Oh, we did. Did we?
Oh, no. The pop didn't have anything in there.
Yeah.
I think it was. Yeah, I think it was top that had it.
Yeah. Anyway, all right. Do you guys need me now, or you guys can carry on? I can take a. You know, I don't need a break really. I just want to give you guys time. I'm happy to just stick around and keep watching, but if you guys want me to step around and step away for about 15 minutes to a half hour, I'm happy with that. You guys want to play on your own? What you should do really is, I don't want one person to drive it, but you should all be trying different experiments with it, right? So you want to say, someone should say, Susanna should say, hey, let's try and push in a few different things and see what happens. And then, yeah, you try various things, right? Even private methods, you know, your toString, you can change your toString, how your toString looks. Maybe not all on the same line, maybe new lines. You can try various things. Okay, try experiment.
Could you post the link to the replit? Yeah.
So you want me to step away? If you guys are good,
I defer
I'm
to what
happy
the
to
list of classes feeling.
I mean, I'm not going to be gone. Like, I mean, you should just be able to call out and I'll be here. Right. But I think you guys are going great with this.
Mm-hmm.
Yeah.
I understand everything in front of me. So yeah.
All right. Okay. Well, I'm here. Okay. I'm here. I'm just not going to be right in front of the computer. Okay. Maybe behind the computer or next door, but I'll be within earshot. Okay. So you just call out to me anytime you have any question at all, right? Call out to me, just chat. I can't be looking at chat window all the time. Is that okay?
Yeah.
Great. All right. Enjoy guys. This is your playground. And you only have one more class and only one more student has a chance to take the screen, right? Now, obviously, if you guys want a class in week 12, I'm happy to do that. But technically, we're not allowed to have lectures with new material in week 12. So Thursday will be our last class. but here's your playground for today, okay? And it's all being recorded, so you can feel free to have your fun with stacks. And next class, we'll take exactly the same thing and turn it into a list, okay? Introduce a few more methods, right? With a stack, you can only insert things at the very top of the stack, right? And with a list, it's exactly the same thing, except now we need some extra methods, which will let you insert anywhere, not just at the top. Yeah, so we need a cursor saying where we are, right? Where we are, instead before, after, and so on. All right, so we can do that next class. But until then, play around with it. You got to get 100% comfortable with stacks and linked data structures. Okay, all right. So call out to me if you need help.
Should I maybe just, is it fine that I participate during this class?
No, Chad, but you can, but you shouldn't take over, okay? So at most one.
I'm talking like with the code.
Yeah, but even code, but it can't be forceful, okay? So everybody's got their own style.
Okay, so maybe I'll just let other people look at, right?
Yeah, absolutely. And you should.
Can I just do nothing today because
feel free to offer your suggestions too, right? Because many of the suggestions are good.
Yeah, because I'm doing, because maybe I'll just offer suggestions, right?
Yeah, absolutely. I think you guys are having a great time, right? And you.
But can I implement my pop int val thing?
You can do it in a separate place, right? You don't have to erase this and implement it. You can implement Chad's pop, right? Chad's _ pop or something like that.
Maybe I'll just copy the code and do it in a separate place. How's that?
Up to you guys. All right, you guys coordinate this, right, in a friendly and nice way. Okay.
Got it.
All right. Good. All right. Call it. All right. Bye. Not bye. Right. I'm just gonna be here, but right out of your camera. Okay. See you later. Bye.
Okay, so what did we want to do with the code?
We have to complete this stack, correct?
Okay, I think last time we left off, we were missing one of the stacks, the destructor one. I believe it's that one, yeah.
This destructor.
Yeah. Do we have to add anything into the destructor?
Oh, that's weird. I thought we already wrote out the destructor, but I guess not.
Because I remember we left it blank last week, so I wasn't sure if anyone filled that in yet. So we could just finish the destructor.
Sure. Would you, Susanna? Would you like to let me know what to type in?
Let me double check.
Yeah.
Sorry.
So I have a suggestion.
Yeah, go ahead.
Can I, is it fine that I implement pop int val? So, because pop is normally supposed to get you value, right? If you pass in int val, I mean, not int val, I meant string value by reference.
Yeah, sure. You're planning to overload it, or are you just gonna overwrite it?
I think we're going to overwrite it.
Yeah, go ahead.
So, if nothing is passed in, it will use the first one, right?
Yeah.
And it will use the second one if you pass the link, right?
Yeah, definitely.
I think that's overwriting, right?
Overloading it. That's overloading.
You're providing a default method, correct?
Yeah. And providing a method if you don't pass in a value, which just deletes it.
Yeah, default.
So for the destructor, I'm guessing we're just going to go through each element on the stack one by one and delete them.
I believe so.
Will we just create a for loop with a pop method, or
Let me double
was he
check.
saying that there's a different way that we should do this?
Well, I mean, here's how I would do it. You can do it. I guess you can do it with a while loop or a for loop.
Mm.
But I usually do it with a while loop. You just keep on checking if top of stack is a null pointer or not.
Mm-hmm.
So while top of stack isn't a null pointer and is actually pointing to something, so this is pretty much equating to is not a null pointer. And you just create a temporary node to take on top of stack. The top of stack is going to move to its next, the next item of the stack.
So is it pretty much shifting all the different things over?
Yeah,
what you want
definitely,
to delete?
definitely. So I mean, it's basically if you have a stack of 5, 4, 3, 2, 1, and then this is the top of the stack.
Mm-hmm. So pretty much you shift it and then you delete whatever you want to delete.
Yeah, so we're gonna create temp over here and then take the top of stack down here. So top of stack is down here, and then you can safely take out this one.
So top would be just next and then delete.
Yep. And
yeah,
then you
okay.
kind of rinse and repeat until you get to the null pointer down here, and top of stack is going to hit that. And then the while loop will see the null pointer and evaluate to false, and then the loop exits.
Okay, that makes a lot of sense.
Yep.
Thank you.
So what we could do is we could add in, and you guys let me know if you have anything else, any suggestions that you want to do. But maybe we could add in, while it's deleting,
Should we have some kind of indicator if something is removed? Yeah, that's a good idea.
Yeah,
so
yeah,
we know
definitely.
what we're deleting as we go.
Yeah.
Why would we use specifically? Wait.
Yeah.
What's the? Is it better to use a while loop or a for loop? Like, what would be the pros and cons of either one? Just to double clarify.
Yeah, definitely. So I guess it's just a matter of style in terms of which one to use. I mean, for me, I think better when it's a while loop for deleting these kind of things. But I'm guessing for a for loop, you probably want to do a node temp goes to top of stack, and then temp is not equal to null pointer, and temp goes to the let's see, temp next.
Okay.
Yeah, something like that, and then you kind of have to do a little bit more
yeah.
massaging with it, but yeah.
Yeah, the while loop looks a lot cleaner.
Yeah, well, I mean, yeah, it's just kind of preference of style, I guess.
Yeah. Okay. Sorry, I just wanted to double.
Oh, no problem. So I guess we could add a little message indicating that we're removing the whatever string it is that we're removing.
That works. Do we also? Okay, so we have delete. Do we have like something that just does clear all as well?
clearing the entire stack. I'm guessing, yeah. So you just, oh, okay, I got you. I got you. Yeah. Yeah, I don't think we have that. Basically, you just kind of want to empty it, but keep the stack still there. You don't want it to destruct, pretty much.
Yeah.
Okay, we could definitely implement a method like that. What would you say is the signature of the method?
Good question. Actually, never mind.
Well, I mean, I think it's a good idea actually to kind of clear out the stack. So if you want to kind of start anew, yeah, we could definitely implement that. Would for a return value, would you say we're gonna do a Boolean return or a void, or yeah, because there's a couple ways I guess we could implement that, and yeah, if anyone else wants to chime in too, more than welcome to. But I'm guessing we could do it with a bool, just to say, just to return whether we were successful, we were able to empty it or not.
I feel like there's already one built in.
Oh, there's already a.
Let me double check. Sorry.
Yeah, no problem.
Hey, Michael.
Yeah.
Maybe we could do a return the size of the stack.
Oh, okay, yeah, that sounds pretty good.
I think we should go with Robert's suggestions first. I think that will be a little bit more interesting.
Sure. So I'm guessing we're just gonna do size t, size. Oh. And then we can go down here and split it down here. So I guess the reason we wrote this function was because we're going to use size t instead of int, because the size should always be greater than or equal to 0. And then we're going to add the const after the size function, because we're indicating to the program that we're not going to change any of the of its internal data. So yeah, and in my opinion, and Robert, you can let me know if that's a good way to go about it or not. I would suggest we add another private variable called size, and every time we push, we add to size, and every time we pop, we remove from size. So when we want to know the size, we can just return the size member.
Yeah, that's a great idea.
That's a great idea.
Okay. Okay. So just going to do size t, because otherwise we'll have to kind of walk through this entire stack just to get the size of the stack.
That's right. Yeah, that makes sense.
So we declare a private variable, a private data member over here. And the first thing we need to do is just make sure that when we come to the constructor, we need to initialize that to 0. And then every time we push, we just need to add 1 to the size. And I'm just used to adding ++ at the end, although you can add ++ to the the front, I guess. Since it's on the same line, it doesn't really make a difference since there's nothing else to it. But I think convention might be to do ++ on the at the front. But yeah, that's just me. And then you can do size minus over here. So again, when we push, we add to size. When we pop, we delete from size.
Yep.
Yep.
Okay, and then in the size function, we can just say return size.
Oh,
Yeah, go ahead.
there's actually a built-in thing where you could do, because you know how we could check empty. There's
Yeah.
one, so stack dot size just works also.
Stack dot
Yeah.
size
Yeah.
empty. Oh, for you mean like a built-in as in like the built-in stack?
Yeah.
Empty
I think.
size.
Yeah. There we go. Return.
Yeah. Yeah. They. Yeah. For I mean, yeah. Those are obviously. I guess obviously when you're actually working on production code, you want to use the library here instead of creating your own stack. But yeah, definitely.
Yeah, what we did here is we created our own stack, right? So
Yeah.
that's why we created a size as well, just
Okay.
because.
Yeah. Okay.
Because
That
we
makes
also
sense.
created a push and pop method, so and those technically come with your stack as well.
Okay. Sorry.
Yeah. Yeah. Because generally you would just do you would just include stack, and that kind of takes care of everything. But it's good to kind of, I guess, write out your own, try to implement your own data structure once to really understand what's going on behind the scenes.
So technically, are these things considered arrays? I mean, I meant, are they considered linked?
They're linked lists.
Like the
Yeah.
arrays are technically considered linked list?
Well,
They're
so the instance of the stack that we implemented was using a link, basically was using how a linked list work. You could also implement a stack using arrays. Yeah, you can do it both ways. I'm not too sure how they generally do it in the standard way, but you could do it both ways. So it's just like Anand said before, this is basically you're wrapping a data structure with another data structure to kind of create different effects as well.
Got it.
Yep.
Looks like he uses a vector normally, but
Yeah, I guess that's kind of what yeah. I was pretty surprised when he wanted to use a linked list for a stack, but I guess it actually worked out.
oh, I guess default container is DQ. Yeah, whatever.
Yeah.
Deck, I mean.
Just letting you know it's 9:50.
Oh, so it is. Does he want us to keep working through it? Cause he typically goes to like 9:55.
Should we ask him?
Who wants to shout really loud into their mic?
You might want to lower me real quick. Give me a second. Professor and
God.
Oh, sorry, I was muted. I was actually saying yeah, and you guys didn't hear me obviously because I was muted. All right. Okay, yeah. What's up? What's up?
We're actually just wondering, it's 9:50. Do you want us to keep working or,
It's up to you guys. If you want to,
Oh.
we've done as much as we need to establish a playground for you guys to just go around and experiment. We got a snapshot of this code and we'll play it so you can't break it. If I say take a fork and play around and turn these things, inside out, really. If you want to do that, that's fine. Or if you want to, any new tricks if you think of, I'm happy to talk about if you want. It's 9:50. It's up to you. So you guys call the shots, really. I'm okay to do it. What do you want to do? I mean, you're good here. Do you have any questions though? I mean, do you have any doubts? Things not working and you're not sure and so on?
I think my one question is, why would you want to implement your own instead of just importing or just doing the include stack?
Yeah, good question. You don't have to, right? The truth is you don't have to. Thank you, Susanna, for asking that important question. And so that's what my 2C students say. Why do we need to learn to implement a hash table or a tree or a graph when all these data structures are out there? We just pick and choose off the shelf, right?
Yeah.
Yeah. So yeah, that is absolutely right. And that is the correct mindset to have. I always say, knowing what they do before you go shopping for which package to use helps you in picking the right thing.
Okay.
So that's why we're learning what constitutes a stack. I mean, what is it? When people talk about stacks, what's this big thing? Is there any magic to it? And now there's no magic to it, right?
Mm-hmm.
Yeah, that's all. So it's just, the whole of CS2A, 2B, 2C, it's all just a sequence of demystifications, right? So it's just demystifying things and jargon that people just bandy around, saying, hey, I know about stacks and linked lists and, inside out.
That's a great way to put it, actually. The further you go along in I guess your programming journey, if you will, the more things become demystified. Things that I don't know. I feel like people, because and it really should be more common knowledge, but I feel like a lot of people don't understand what programming is fundamentally, and they seem to just overcomplicate the language around it. I don't know, so maybe it sounds more impressive or cool than it actually is, but in reality what that does is it gatekeeps a lot of people away from programming, because they think, hey, this guy said something that sounds extremely complicated, but really if you tried to implement it, it would be fairly easy to do, or fairly easy to understand. And I don't know, it's just
I think so too, right? I mean,
yeah, I agree with that.
I agree. So do you know I also think so? I think I know why we have to make linked lists.
Why? What? Sorry. Why?
I think I figured out why we need to implement linked lists. It's to understand how vectors work and all that.
Yeah, not vectors per se. Yeah, but certainly to understand how pointers work.
Cool.
It's really practice, right? So it's practice. I mean, nobody wants you to implement a linked list, right? Even if you go to a company and start working, they're going to say, "Hey, start off implementing a linked list." So
they're just going to have you use vectors.
No, it's just different ways in which you use pointers to get familiar, right? So is it when you learn pottery, there's a certain technique to finish rocks or finish a thing, but you may learn it in the context of a plate. Right? But it is exactly the same technique that you would use for a pot, you would use for some other complex shapes, or even for a none on the wheel, right? Same technique. But what the masters will teach you is not, here's technique A, technique B, technique C. No, it's one technique, but let's apply that technique in 5 different places so that you don't think of it as, A prime, A2 prime, A3 prime, A4 prime. No, you just think of all of them as A, with just minor more variations to adapt. Right, so essentially, what a stack is, and then you adapt it, just tweak it. You got a plastic jelly, right? So you want to tweak it to fit a particular situation, tweak it, and that's where the expertise lies. Experienced programmers take the closest match, and they know where to polish off so that it'll fit in the new hole. That's really all there is. right? Non-experienced programmers will try and take a square peg and jam it down a round hole, or vice versa, because that's all they know, right? All they know, they don't know how to polish the edges off, because they don't know how it works. They know it does something, but they don't know how to change it to do what they want. So they will bend their own, they'll adapt to the tool rather than letting the tool adapt to them, which, sometimes is a good strategy, right? It's a good strategy for us to adapt to the world rather than getting the world to adapt to us. But sometimes you got to play it by ear, and yeah, you're absolutely right, Nick. Yeah, sometimes, it's just demystifying. Everything is so simple, but many people who don't understand it think it's complex. And the danger is that they become gatekeepers. Gatekeepers, not in a formal sense of the word, right? So again, gatekeepers, no, you're not allowed, not in that sense. It's just surreptitious, insidious gatekeepers. In the sense they did.
Sorry, but Michael, can you post the link, the new version on Reddit later on?
Yeah, no problem.
Okay,
Great.
thank you.
I'll see you guys.
So I have a question.
Yeah, sure. Go ahead.
I was talking to Michael, the code. I was wondering, why is it saying removing on the code output? Is it running the destructor after code's finished executing?
Yeah, I just added a little snippet over here during the destructor to indicate the data we're removing.
I just was curious because I just want to make sure that there's nothing wrong with the program.
Oh no, we added it in so that we could visually see what we're removing.
Yeah, because
Oh,
you're
good to know.
kind of removing from the top of the stack. You can see removing world first, and then removing hello, and then you reach the bottom.
So we could probably just get rid of it if we know it's working great.
Well, maybe it's a good thing to have, especially in case of like debugging. If something's going wrong, then you can actually see what's happening.
Oh, good to know. Especially when making a game, I definitely would think that'd be important, right?
Yeah.
When destructors.
If you want to do debugging like this without using cout, you could probably print straight to console, correct? I'm assuming you can.
Yeah, or I'm guessing you could print to a log or something.
Yeah.
Yeah. I think it was just good to see this visually, consider we're doing all these by ourselves. So it's like
That's what I meant,
Yeah.
Like I've seen this with video games, I think, but console out. I think they do that with a lot of things, to make sure so programmers see if the things are working, right?
Especially when you're designing a video game, it's like, or something like that, you have a lot of moving pieces that were not initially designed to move with all of these different pieces. So if you add something new and you keep adding new interactions, implementations of new features into your game, eventually everything gets very complex and convoluted. So instead of
Yeah.
having to go back into your code and recreate console prints or log prints or trying to debug, not even debugging your code, trying to debug what your code exactly is doing again, like looking through each little line and figuring out, oh, that's what it does. Or you could have just put a thing that calls out what it's doing when you coded it in the first place. So that way.
So I think a lot of games technically do this, right? But they just hide it from the user, right?
Yeah.
Oh yeah.
Oh yeah.
Every program needs the debug logs. Every serious program needs debug logs because as programs become more and more complex,
Cool.
they just become more complex, and you can't run it through your head and expect it to work 100% of the time. There's always things that go wrong, and you want to know why they go wrong. So that's why you print out whatever error or log you want to print out.
Oh, makes sense to me. Makes sense that I just was a bit worried about the console that people would see it, but now I know from a video game standpoint.
And then
It's
also
nothing more. Because the console isn't really visible user, right, when the game's released, right?
Oh, what were you gonna say, Nathan?
Oh, it just in video games, I'm pretty sure when they show you like in a console, they selectively show you what goes in there.
Yeah.
because they don't exactly show you the command terminal inside of the video game. That's kind of just a nice UI that just shows you logs, and you're usually I guess generally you're supposed to send that to developers or
Yeah,
something.
that's what I'm talking about. You know, like I've heard of a log file, and sometimes, you know, I think they save the hidden console output, if I'm correct,
Pretty sure
to log.
that we're getting a little complicated, but I'm pretty sure you're just from the sense of when I go and look into a game file that I have on my computer, it does have its logs there. Which when I go into, I never understand anything that I'm looking at, but normally show an execution of what's going on. Obviously not like specific the way you put it actually is smart action, where you were like it doesn't show you everything. It just like says like essentially the logic of it, but without saying explicitly what the code's doing.
And
guess.
also the console's not visible to the user,
Yeah, and then
They're
something to keep in mind in general,
but the logs are.
most companies, big companies, they have different internal tools as well
Mhm.
that the customers do not see that helps them debug, because you have to keep in mind of the software development lifecycle where whatever gets pushed is what your users see. Not everything will always get pushed into production.
Oh,
it.
that's true.
Yeah.
Maybe I'll
because-
try with my own games. Maybe I'll try logging a lot of things
Yeah.
in case it crashes, so
And
I can
then
send a crash report, right?
yeah, and then
You
also
can do-
based on my personal experience of running a small RuneScape server, like we had a lot of logs that we would have that would help us debug, but it's not like the users would see at all. You have to keep in mind that there's a lot of internal tools that you could have, but you won't always see versus what the users see.
Cool.
Mhm.
Yeah, makes sense. And so when a game is running, is it technically you know, when they do these logs, they save it if it like, you know, there's an error or something, right? That's one way to do it, and you can store the console output in memory.
I think games will all create their own system for creating their own crash reports, but essentially that is a way to do it, if I had to assume.
Because, you know, maybe that will be my way as an independent game developer. You know, maybe I'll print out console out on important stuff in the game, you know, that player normally doesn't see, but when the game crashes, it saves to a log, right?
Yeah. It's like similar to the example that Peter brought up on Reddit, the one about the League of Legends.
Oh, that's how people found it out. It was the logs.
Yeah. That's
Yeah.
generally a lot of games have crash reports, don't they?
I'll see you later.
A lot of the time they just send it to their own servers for analysis, but that's kind of iffy because of privacy laws and stuff. But
I've
yeah.
always wondered that because they'll say submit a crash report, and I'll be like, okay, and then I'll think in my head and I'll be like, so I can't like see any of the actual code for this game because that would be bad. Like when games get hacked and their source code gets released, it's normally a big deal. And so like there's no way that like I'd be able to see that. So like how is it able to submit its crash report from my computer to their servers without
Because-
ever like me having any visibility of it? Not that.
Well,
Yeah.
That's a great question, and I don't know the answer to that. I know that there are very specific laws, especially in Europe, and if they don't follow them, well then they get sued for a lot of money, and those laws are regarding data and privacy and whatnot. And you know, generally games don't really need like those kinds of logs. They don't need much, but obviously they can take they obviously can take they can take personal information. However, that would be violating a lot of privacy laws. So I don't think that they do. And also game source code getting leaked, it's not really a bad thing. It's actually very common, and it's very useful to that game's community, because uh, that's what a mod is for a game. Basically, it's literally just a
Yeah,
modification of the
yeah.
source code.
Yeah,
It,
I was thinking more so along a
I'll see you
competitive
later.
game lines, because there's a lot of scrutiny around that, I guess. But you're
You
right.
also,
Modded. I know that's how mods are designed.
I'll see you
Um,
later.
Not the concept of, or I know the concept of it, not the specifics. But yeah,
Okay, bye.
Bye.
Hi, Chad. Um, I remember there was this. I saw this kind of funny article. Well, basically, games are kind of used to people seeing their
futzing with
source
their
code.
stuff. Yeah.
Like there was this funny article where I don't know, I saw it somewhere. It might not even be true, but I thought it was funny. Where people in Steam, or sorry, people in Valve got paid to remove swear words from the comments inside of the code. And it's like they're prepared that people are going to look through the code. So I don't know. And it's also funny because Valve is notoriously just Valve developers notoriously are just notoriously depressed because of the of the
There's
code
so
base that they're
many
given.
errors.
Yeah.
I think, I don't know. It's interesting to see like the more you play games, the more things you notice about the code. You're just like, oh, this is very broken. Like for
Oh
example,
yeah.
with Valorant, one of the every time they push out a new update, there's always something wrong. And I think like they should have implemented something similar where like they have like with League, they have special service that they roll out to first. Valorant doesn't have that actually.
Yeah,
I
I'm
just
honestly very surprised by how broken the client is for Valorant in specific. My personal client is just a mess. And it's funny because normally part of like the post I put on League, but like in general, it's like normally I would just sort of write it off as like kind of magic. Uh, it's just sort of magic, like things break, and like that's the gist of it. That's all I know. Like sometimes I'll get a new game and it'll just crash all the time, and then it'll just magically fix itself at some point. Likewise with my Valorant, like my client does not work like 90% of the time when I first started up. It'll be like at least third or fourth try. In some way, shape, or form, it'll be broken. It's never the same bug either. And yet, at some point, I restart it and it just magically fixes itself. And I don't know, but as I learn more and more about code, the more and more I'm like, okay, the reason why it just magically fixes itself and the reason why it magically broke in the first place is because something's just very, very, very wrong with this code. There is something in here that is not getting addressed whatsoever.
Could even be some
I
sort of memory leak.
Yeah.
Oh,
I
one.
play CS:GO, and
Hmm.
I don't really have to worry about updates breaking the game because the game never
There are no
updates.
updates. Yeah.
Yeah, exactly.
That's fair. Yeah. The last time they introduced a new gun, it literally broke the system.
Yeah.
I used to,
I
that
think
was childhood. Uh, yeah, I mean, like, for instance, with CSGO, like, it was a big deal. I remember, like, around I think it's been a year now, where portions, I think, of an old version of CSGO got, leaked, like, its source code got leaked, and, like, people started, like, screaming as if the world was going to set it on fire. And, Valve kind of said, like, uh, it's it would be a big deal if it was a like current patch, but because it's from like 2017 or 2018, it's not that big of a deal. And it was something that was already leaked, actually. It was just the notice of the leak made it a lot more widespread. But yeah, it's something like that that surprises me, I guess. Like, it does surprise me still where I'm like, the source code is not something that you can just view in all the time. Like, it's never really something I've tried to look up before. But when I look at other news, I guess, I'm surprised to see it be a big deal when I'm like, it runs. I don't know the specifics of it. That's why I'm confused. Where I'm like, I mean, it runs on my computer. Like, uh, has no one really tried to like take what runs on their computer and like break it down? Or
The
like, and I
reason
know like a lot of things are server side, but like, I feel like if they give you all the pieces required to play the game, I'm confused how it's not easier to deconstruct that into figuring out how the game runs from a coding standpoint.
it is, and the reason why it was a big deal is just because it'll be, well, the only reason why, other than, you know, other than selfishness, the only real reason why game developers don't want their source code leaked is just it makes it infinitely easier to make hacks for the game.
Hmm.
And it just, and obviously hacks ruin the experience for people.
Yeah,
Um, you know, it's easy to make mods, which are great for the game, but it's also easy to make hacks for the game. For
technically
the game.
mods are
Yeah,
hacks
kind
in
of
a
a,
way, so yeah.
yeah, it's a double-edged sword there.
Hmm.
Um, and if it gets leaked publicly, obviously, you know, like the process now, at least what I'm guessing, for people who make hacks for a video game or mods is, you know, they have some sort of decompiler, deobfuscate, whatever, for the code that they run, and they have to make that and figure out the intricacies of how they protect their source code, and there's a bigger barrier to entry there, so not anyone can make a hack. But if the source code is completely gets leaked, then the barrier to entry is much lower, because it's like, hey, I can look on GitHub and I have the source code, and I can, you
Hmm.
know, spin bot all
Yeah.
game. Look at me.
Because
Uh,
that could be like, like with private servers for like RuneScape, MapleStory, Minecraft, different private servers. It's like that.
Yeah.
Or
And I can see like, I mean, I've seen videos of like, obviously I think everyone has modded CS:GO or modded Valorant or modded
Mhm.
anything really. Uh, so that's why I'm surprised. I'm like, if people know enough of the code of the game to create mods for it, I don't know. And it's not like a huge deal when someone creates a mod. Like,
yeah, but Riot just wants to keep sucking our money.
yeah, I don't know. I really don't get it. I'm like, how, I don't get the two pieces of like, how is the source code so easily protected when it runs on my computer? And B, like, also, if it is so heavily protected, then how is it also seemingly easy for people to modify the game? Question
it's
mark.
um, it's protected. There are a lot of ways to protect source code, especially in C++. While nothing is like infinitely protected, uh, there are a lot of tricks you can do, and I'm not entirely aware of a lot of those tricks. I just
Hmm.
know that they exist, and
Well,
I-
example would be like secure programming specifically, because there's like a difference between regular programming and secure programming. I learned a
Okay.
little bit about it while interning, and then they uphold certain standards that, oh, what you can and cannot do, that makes it more secure.
Oh, huh.
yeah, and and it isn't easy to get the source code for quite a few games. I'm not sure about CS:GO or Valorant or any specific games in general, but
Mhm.
I know that generally acquiring the source code of a C++ program is difficult because it's it's compiled to binary, right? In the end, so that's hard to. I mean, it's kind of hard to figure out what's going on there, but
Yeah.
Well, a lot of people do just do reverse engineering because that's when assembly starts to come in and stuff.
Yeah.
Yeah.
I mean, yeah, that's why I was kind of going off of the lines of it's like if I were to like try and figure out the source code for a game, I'd probably start with just seeing what exactly like the functions of the game itself, and then using whatever I can already glean from what's on my computer to just start deconstructing until I get the exact same product, I guess. But I don't, obviously I've never gone about doing that, so I don't even know how feasible that is. But
Yeah.
I meant machine code earlier, by the way, not binary. I know.
yeah,
C++.
I
Yeah, yeah, yeah.
inferred what you were
Yeah,
saying,
yeah.
and I'm not gonna lie, I don't think I didn't know uh at the time, like 10 seconds ago, I guess, that it was called machine code either. I was just kind of like, yeah, he means the thing that the computers do.
I think we just we're I think we all are on the same page of what we meant.
I
Yeah.
actually I googled it. Now I'm even more confused. Because I thought it was machine code before. I don't know why I said binary, but now I'm seeing machine code, binary, and assembly. So those are different. Those are all very different answers. But whatever.
Are they
Uh,
different or are they the same answer? Like, are they all
uh,
just?
assembly is an even lower level language than C++,
I
and
figured, yeah.
uh, yeah, and binary machine code. I mean, that's the same thing, right? So I don't know. I guess I'll ask
I
Anat
mean,
next
maybe
time.
assembly is I mean, don't quote me on this, but assembly might be the lowest level program that could be understood by and like coded in by a person. So maybe that's why, like, it's saying like assembly is like the lowest level you could go down to
Yeah.
understand it, and then past that, there's binary machine code, but like no one wants to touch that. Can you even like code in machine code? Or is that
Yeah.
like
But
I
ain't nobody got time for that.
yeah, I was like, I think so, cause like a Turing machine like is literal binary. He somehow managed to code in binary. Like somebody had to do it. Somebody had to or I guess not reverse engineer our languages, C++ and whatnot. And in order to do that, they had to understand machine code, one would
Yeah,
assume.
obviously. Yeah.
So
Yeah.
yeah, and also computers didn't just magically show up out of nowhere. So since we designed them, someone had to understand it. It's just a weird concept to think about. Like someone had to actually do that, like figure it all out in machine code. Damn, that sucks.
Cause so one of my mentors, she works with us. She's a malware researcher specifically.
Mhm.
So she does a lot of reverse engineering with malware, and she uses assembly and C++ a lot.
Oh,
Yeah. So like apparently a lot of malware is written in C++, and then she just reverse engineers it into assembly most of the time, and that's how she's able to really analyze it.
huh.
Yeah.
I wonder. I guess
That's
assembly might
hard.
give you more information because it's lower level. So,
Yeah.
huh. That's interesting. Could you do the same thing in general for higher level programming, I wonder? Like, could you like take, for instance, like Java and then convert it into a different language and maybe glean more of what's going on, I wonder? Or like, would that even be helpful? I feel like it wouldn't actually. Maybe? I don't know.
Well, I mean, you can't just convert Java into, I don't know, Python or something, but The reason why you can go from C to assembly is because C is made in assembly.
Oh,
You can
true.
probably do Java to assembly because there's
Yeah,
the hierarchy is Java, then C, then assembly in terms of which languages
Yeah.
you know, more interpreted, I guess.
I was thinking that as well, because I was like, there's so much in like Java that's done like automatically. I don't know if it would help to turn it into a manual process, but I don't know.
I'll just send you something real quick.
I am going to go because it
Yeah.
is
Okay, okay,
10:50
bye,
or
bye.
10:20. Sorry.
Okay, time to
Goodbye.
go. This
Yeah,
one
I'll
went-
leave
this
as
went
well.
It
really
was
long.
this was an interesting conversation.
Yeah.
We like speculating.
Yeah.
Yes. Bye.